Hello everyone, I'm here to present an analysis of Australian house price. The dataset contains details of the price of household in Victoria from 1989 to 2020 and is was obtained from the Victoria Government Australian website. The summary of the dataset shows that over the 20 years period, on average, a house was sold at 450,000. The highest sale was recorded at nearly $1 million, and the lowest is at about 150,000. The time series report displays clear upward trends, indicated that the house price have increased over the years. There is no changing variance, repeating pattern, or a behavioral change point in this series. Lastly, as there are succeeding time points and no fluctuations, the behavior of the series can be confirmed to be an autoregressive series. Initially, the model was assessed for non-stationarity. The ACF port displayed slowly decaying pattern, and the PACF port had a last leg one significance. The ADF test was also not significant, therefore it was concluded that the lower series is non-stationary. Bocott transformation was applied to the original dataset. There were no improvement with stationarity or normality, but slight improvement in this time series report. So for this reason, we continue using the transform series to do the different things. However, the first difference was not successful, as the ADF and Philip parent tests were not significant. Taking the second difference of the series converted to the stationary ones, the time series report in this slide show no trend and a flat mean level with mostly MA behaviors. There is no decaying pattern in the ACF port and high lag one in PACF, and all three non-stationarity tests confirm stationarity of the series. For model specification tools were used to determine a value of PD and Q. As it shown on this slide, there are 8 possible models that we contain from those two. Of the suggested 8 models, the only model that has a significant coefficient was the ALIMA 021. It also has the lowest AIC and BIC scores. Considering the earlier measure, however, the model ALIMA 224 has the least value for those measures. So for this reason, the residual analysis was conducted for both models. However, the residual analysis of ALIMA 021 had a better result compared to ALIMA 224 model, as is shown on this slide. The time series report shows a random pattern suggesting that the original model captured the trend of the series. And the histogram appears to be symmetrical with, however, a presence of outlier toward the left of the tails. If the distribution considered from the limit -2 to 2, the residual would display a clear normal distribution. And also the QQ plot showed that most of the points align along the reference lines, while the Chabriot test confirmed this observation with a p-value of 0.31 that is greater than the 5% significant levels. Lastly, the ACF plot and the jukebox test confirm that there is no autocorrelation left in the residuals, as all legs are within the reference line in the ACF plot and above the reference line in the jukebox test. So that we conclude that the ALIMA 021 model passed all the diagnostic check, and it is the most suitable model for forecasting. Thank you so much.